37 seconds. That's how long the most advanced rocket in Europe survived after launch. On June 4, 1996, the first Ariane 5 lifted off from French Guiana. It was powerful, ambitious, expensive, and 37 seconds later, it self-destructed. The explosion wasn't caused by an engine failure. It wasn't weather. It wasn't sabotage. It was a number. To understand what happened, we need to go back. Before Ariane 5, there was Ariane 4. Ariane 4 was reliable, proven, successful. So when engineers began building Ariane 5, they reused part of the Ariane 4 guidance software. That decision made sense. Why rewrite code that already works? But Ariane 5 was not Ariane 4. It was larger, more powerful, and most importantly, it accelerated differently. Inside the rocket was an inertial reference system. Its job was to measure velocity and orientation, and feed that data to the flight computer. During flight, a 64-bit floating point number representing horizontal velocity needed to be converted into a 16-bit signed integer. In Ariane 4, this was safe. The value never exceeded the limit. In Ariane 5, it did. 37 seconds after launch, the number grew too large. The conversion caused an overflow. The software shut down. The backup system activated, but the backup system was running the exact same code. It failed the exact same way. With no valid guidance data, the rocket's control system interpreted the diagnostic data as flight data. It made violent correction commands. The rocket veered off course. Aerodynamic forces increased rapidly. The structure began to break apart, and the onboard safety system triggered self-destruction. $400 million gone in less than a minute. This wasn't a random bug. It wasn't incompetence. It was a design assumption. The assumption that software proven in one system would behave safely in another. The assumption that limits would never be exceeded. The assumption that redundancy meant safety, even when both systems shared the same weakness. The failure wasn't in the code itself. It was in the decision to reuse it without fully revalidating its operating conditions. One design choice: reuse without contextual verification. In complex systems, small mismatches scale violently. A type conversion, a boundary not reconsidered, a backup that mirrors the same flaw. Ariane 5 eventually became one of the most successful launch vehicles in history. But its first flight remains a reminder. Reliability is not transferable by assumption. Redundancy is meaningless if it is identical. And in tightly coupled systems, a single unchecked constraint can bring down everything. 37 seconds. That's all it took. One design choice. Total system failure.